Hey guys, I'm sorry I can't be with you today, but I wanted to go over some notes with you guys. So today you're going to be learning about standard form. So if you go into Google Classroom, guys, you are going to find the quadratic guided notes. You actually already have these. This is what we took notes on the last time. So if you can find these notes, please, graph and quadratics, that would be awesome. If you can't find them, open them up through Cami and take notes that way, or ask Ms. Steele, the sub, for a piece of graph paper for you to take them on. I don't really care which. Just make sure that you have a piece of graph paper or this actual piece of paper to take your notes on. Okay, so let's talk about standard form here. So we talked about vertex form. Vertex form had the parentheses. Standard form, you guys got introduced to what standard form looked like last class because we were converting vertex form to standard form. And standard form is your ax squared plus your bx plus c. And honestly, this should look familiar to you guys because this is what our graphing looked like. Okay, so that is what our equations are going to look like. So what we're going to be doing when we graph in standard form. So step one is going to be to find the vertex. Okay, and to find the vertex, this actually gets broken down into two different parts. So the first part that this gets broken down into is one, the axis of symmetry. Okay, and the axis of symmetry, guys, if you go back to when we first talked about all the different parts and pieces to a quadratic, we talked about the axis of symmetry is what goes down the vertex, okay? So we know that this is an equation, x equals, and there's actually a formula here. It's x equals negative b over 2a. Okay, so that's the first part of finding the vertex. So this is going to be the x part of the vertex. The other part of the vertex, to find the y value, we need to take that x value, okay, and you need to plug in to the equation, okay? That will give me the y value of my vertex. So the axis of symmetry will give me the x value. Once I plug it back in, that will give me the y value. All right, the last part of this is to find the c value, okay, which is your y-intercept, and reflect. Okay. So again, we're going to go through what that all means, but those are the basics for right now. So let's look at our first example here. We have x squared minus 6x plus 11. So my suggestion is to start by identifying what your a, b, and your c are. So we know that it needs to be ax squared plus bx plus c. So here, the number in front of my x squared is really a 1, so my a is 1. My b, -6, and my c is 11. Okay, so what we want to do here is we want to look at finding the vertex. So to do that, we first need to find our axis of symmetry. So we need to write down our formula, negative b over 2a. And we need to substitute in here. So it's a negative. Now be careful, b is -6. So it's a negative 6 all over 2 times a, which is 1. You just do a little math here. And -6 is a +6. 2 times 1 is 2, and we get 3. So our vertex here, we know it's going to be 3 comma something. Okay, we know that our axis of symmetry is going to be at 3. So what we can do on our graph here is it's x equals 3 for our axis of symmetry. So I like to come over here to 3 right here, and I like to draw this little dashed line down, okay, because this tells me that is my axis of symmetry. Okay, so my vertex is going to be somewhere along that line. And symmetry, guys, think about symmetry. That means that everything's going to be reflected. So whatever you have on one side of that line, it's going to be reflected the same thing on the other side. Okay, so let's keep going to find the rest of our vertex. So now we need to plug into the equation. So I need to take my equation that I had, y equals x squared minus 6x plus 11, and I'm going to take this 3 and I'm going to plug it in for my x. Okay, so now I'm going to have 3 squared minus 6 times 3 plus 11. Just doing a little math here. 3 squared is 9 minus 18 plus 11. You can plug all of that in the calculator and you will get 2. So that means my vertex is 3, comma 2. Okay, so now I can take that information and I can now plot that point, 3 over 3, and then up 2 right there. So that right there is my vertex. Okay. Now, we also need to look at here, guys, we need to find our y value. All right. And our y value here, our y value, or our y-intercept, I guess I should say, not y value, or y-intercept, okay, is going to be our c. So we can see here that our y-intercept is going to be 11, okay, because that is our c value. So we count here on our y-axis and we can see, uh-oh, that is not going to fit. Okay, so we're going to have to make this a little bit smaller, or we need to just change our scale here. So instead, I'm going to count by 2s. Okay, and now my y-intercept of 11, 2, 4, 6, 8, 10, is going to be right there. Okay, so I have my y-intercept. Okay, and now I can reflect that. So I can see that it is 1, 2, 3 spaces away from my axis of symmetry. So I'm going to count 3 spaces the other way, 1, 2, 3, and I can get my other dot there. Okay, so now that I have those points, I can now go and draw my curve, put arrows on each end, making sure that it's a curve, make sure it's not a V. Okay, V would be absolute value. These are not absolute value. This is a quadratic. All right, and then we can talk about some other information as well. All right, this graph is facing upward. Okay, it is up because my A value is positive. Okay, so I know that it's facing upward, meaning my vertex here is a minimum because it's at the bottom of the graph. Okay, and my minimum value there is going to be, oh, that did not work out, did it? Oh no. Okay, my vertex is now messed up because I counted by something different. Okay, so we actually need to move my vertex. Hold on. 3 comma 2 is my vertex down there. There we go. Okay. So my vertex here is a minimum, and the minimum value there, or the height, the minimum height, is going to be 2 because that is our y value. All right. All right, guys, let's try another one. Okay, move on down here. Okay, so again, we want to start by identifying what our A, B, and our C are. So our A value here is going to be -1, our B is 2, and our C is 2. Okay, so as we said up top here, the next thing we want to do is find our axis of symmetry. So our axis of symmetry, and finding our vertex, so axis of symmetry, you have your formula here, -b over 2a. So we have a -2 over 2 times -1. So we get our axis of symmetry being 1. So that means that our vertex here going to be 1 comma something. We don't know what that is yet. So we have that our axis of symmetry is 1. Okay, so let's draw that axis of symmetry going through here. All right, and we can just label this as our axis of symmetry. So we know that we can reflect things across this line. All right, so now we need to find the rest of our vertex. So to do that, we need to take our equation, y equals a -x squared plus 2x plus 2. And we need to substitute this 1 in. Now, this is where, guys, you need to be very, very careful. And the reason you need to be very, very careful is this is the part that I see most people making mistakes on, and that is because of this right here. Okay, what this really means is that you are taking 1 squared, then plopping the negative with it. Okay, so 1 squared means 1 times 1, which is 1, and that negative is just getting brought down. Please be careful. You are not taking -1 times -1. -1 squared or -1 times -1 gives you a +1. That's not what we're doing. It's 1 times 1, which is 1, then bring the negative down. Okay, keep going here. 2 times 1 is 2, plus 2. So we get our other part of our vertex to be 3. Okay, so now I have my vertex being 1 comma 3. All right, so I have here a vertex. Okay, and then we have a y-intercept of 2, because that is our c value. Okay, so I can put my y-intercept of 2. Now, this might look a little bit different than the last one, and that is because we have something very interesting going on here. We have our a value being negative. So what that means when our a value is negative, that means that our graph is going to be reflected. So this is going to face down because the a is negative, okay? Which that should be making sense, guys, because if you think about how this is going to be graphed, we're going to be graphing this upside down here. All right, so we have our y-intercept here. That y-intercept is 1 space away from our axis of symmetry, so that I can just reflect that going across. Okay, and then we can go and connect our dots here to get our curve. All right, and we can also add to this, and we can say that we are going to have a maximum here. Okay, and because we have that maximum, it's because the graph is turned upside down and our vertex is actually at the top. Okay, and our maximum value, the maximum height, is 3. Okay, so I just gave you guys a whole lot of information there. All right, don't forget, guys, that you can also go and plug this in the calculator. Okay, if I would bring my calculator up, you can plug this into your y equals. Okay, you can hit your graph. You can then hit second graph again, and you can get a table of values. Okay, the table of values will also give you this information, will also give you more points that you might need down here at the bottom or to continue. Okay, or for example, on the first one there, if you didn't want to count by twos, all right, here for your graph, you could have went and gone through and found out what the points were for that graph. Okay. All right, guys, so here are your notes for graph and quadratics. Please make sure you refer back to this video, that you go back as many times as what you need to make sure that you have accurate notes and good notes. Okay, all of your work is now posted in Google Classroom. Take a look at the class agenda, what you're supposed to be doing next. And please make sure that you are asking Ms. Steele for help. She knows the math and she knows how to graph quadratics as well, so she can help you out. If you have any questions, please ask her. And if not, please email me. Also, make sure you guys get your homework done over the weekend. And please make sure that you are checking and you are reading your directions as well for your homework. All right, guys. See you next week. Bye.